In this video, I'm going to show you how to graph linear equations. We're going to start out by plotting this function, y equals 3x minus 2. We're going to plot it on this set of axes, and in order to do that, we're going to make a table of points. We've got some x values here that we're going to plug into the function, and then we'll get out some y values, and then each pair x and y will correspond to a point that goes on the graph, and then we'll connect the points in whatever shape they seem to form. So let's get started. X equals negative 2. Let's plug that into the function here. So 3 times x is negative 2, and then minus 2. That equals, well, 3 times negative 2 is negative 6, and then minus 2. And that comes out to negative 6 minus 2 is negative 8. So negative 8 goes here. Okay, now we've got a point negative 2, negative 8, and we're going to put that on the graph here. So we'll go to negative 2 here on the x, and then on the y we'll drop down to negative 8, and that's this point right over here. Alright, great. First point is done. Now it's back to our table to find the next point. We'll plug in negative 1 for x now. So 3 times negative 1 minus 2, and 3 times negative 1 is just negative 3. Then minus 2 makes negative 5. Put negative 5 in our table, and now this is the point negative 1, negative 5. Let's plot that here. So go to negative 1 on the x, come down to negative 5 on the y. That's this point right here. And we'll just keep on doing this. So 0 goes in for x, 3 times 0 minus 2. Well, 3 times 0 is just 0, so minus 2, and that makes just negative 2. So negative 2 goes in our table. Then we've got a point 0, negative 2. So x is 0, y is negative 2. Put that on our graph. And 2 more points. X is 1, so 3 times 1, and then minus 2. And 3 times 1 is just 3. 3 minus 2 is equal to 1. So the point 1, 1. X is 1, y is 1. Put that on our graph. And the last point with x is 2, we'll plug that in. 3 times 2 minus 2 equals 3 times 2 is just 6, then minus 2 makes 4. So the point 2, 4. And we'll put that here, 2, 4. So right up over here. So now we've got a few points plotted. Do you notice anything about the shape of this graph? Anything special about the way these points are arranged? It looks like they might be all on the same line. Let's get a ruler and check that. So are they on the same line? Well, yeah, indeed they are. Look at that. They all lie on this line that passes through all of them. Cool. So we did it. There's the graph of y equals 3x minus 2. We made some points, we plotted them on the graph, and we found they all just lie on a straight line. This leads us to a big idea about linear equations. The big idea is that the graph of any linear equation will be a straight line. So it's not just the one we did in the previous example, but also any other linear equation like y equals x plus 1 or y equals 3 minus 2x. It's just a straight line. All the points just lie on a single line. And that makes it very easy to plot these linear equations. Since they're all in a single line, we really only need 2 points in order to draw the line. For example, here for y equals x plus 1, we've plotted a whole bunch of points, but we could really just choose any 2 of them, and the line through them would be the same. So why don't we say choose that point here, and how about this point here? So just 2 kind of random points on the line, and if we connect those 2 points, then we should get the same line as before. And let's do that. Let's connect those 2 points. And yeah, look at that. It's the same exact line. It's right on top. So from now on, when we plot linear functions, instead of making a table and plotting a whole bunch of points, we'll just choose 2 points and draw a line through those. Here's an example of using 2 points to plot a line. So we want to plot the function y equals negative 4x plus 1, and we know this is a linear function because the power of x is 1 and the power of y is 1. They're both powers of 1, that means it's a linear function. And since it's a linear function, we know that the graph is just going to look like a line. can be angled in one of many different ways, but overall it's just going to be a straight line, and all we need is 2 points to construct the line. We'll just plot those 2 points and then connect them with the straight edge. Okay, so we've got 2 points here. We're going to plug in x is 0 and x is 1, and we're choosing x is 0 and x is 1 just to make it easy for us to compute the points. It's a lot easier to plug in 0 than it is to plug in, say, like 9 or 20 or something like that. Okay, so let's just get on with it. X is 0, let's plug that into the function. -4 times 0 plus 1, and the result, -4 times 0 is just 0, then plus 1 will make 1. So y is 1. So the point 0, 1, we'll put that on our graph. That's right over here. And then x is 1, we'll plug that in here. So that's -4 times 1, then plus 1, which is -4 plus 1, which comes out to -3. So that's the y value in the second point. The second point is just 1, -3. So that's 1, -3. We'll plot that right over here. And now that we've got our 2 points, we can just take a straight edge and connect them. We're just making a line through these 2 points. So let's try to line it up and be very precise here. And here's the line that goes through the 2 points. So there we have it. There's our graph. For our last example, let's test which of the following points lie on this line, y equals 6 minus 2x. We've got 3 points here, 4, -2, 0, 5, -1, 8, and for each point we want to tell whether it lies on this line. The way we can do this is we can just substitute the x and y values of the point into the equation for the line. If the equation evaluates to true when we do that, then yes, the point is on our line. And if the equation evaluates to a false statement, then no, the point is not. So let's begin with this point. X is 4 and y is -2. We'll just substitute it in here and we get -2 is y. So -2 is equal to 6 minus 2 times x. Here x is 4. So 6 minus 2 times 4. And let's see how that turns out. So simplifying this, we've got -2 equals 6 minus 2 times 4 is 8, and then -2 equals 6 minus 8 is -2. Yeah, so this is good. This is a true statement. So that means this point 4, -2 is indeed on our line. Let's go ahead and plot it. 4 and -2 is right over here. Great. Now let's test our next point, 0, 5, and we're going to do this in the same way. We'll just go ahead and substitute our x coordinate in and our y coordinate in and see if our statement evaluates to true or false. So y equals, well, that's 5 equals 6 minus 2x, so 6 minus 2 times 0. So is this equation true? Well, let's see. So 5 equals 6 minus 2 times 0 is just 0, so this is 6 minus 0. So we simplify, we get 5 equals 6. And no, this is not true. This is false. So this point is not on our line. Nope. But let's plot it anyway, just to get a feel of where it is. So 0, 5 is right up over here. And now to deal with our last point, again, we'll just substitute in. So y equals, that turns into 8 equals 6 minus 2 times x, and here x is 1, -1. So that turns into 8 equals 6, and then 2 times -1 is just -2, so this is like 6 minus -2, so that becomes 8 equals, well, 6 minus -2, it's double negative, so those cancel into positive. So 6 plus 2, 8 equals 8. Yeah, that's a true statement. So yes, this point is on our line. And let's go ahead and plot it. -1 and 8. That's right over here. And now that we've got 2 points that are on the line, why don't we just go ahead and plot the line? 2 points is all we need. So let's just go ahead and draw our graph of the line. So what does our graph look like? So it's just about like this. Okay, so there's our line, and wow, it seems like we just barely missed that other point, but still it's off the line. Off the line is off the line. So yeah, this is our line, and two of these points are on, that other point is not. In these examples, we were working with lines that had two variables in the equations, x and y. But in the future, we'll also learn how to graph lines that have only one of those variables in the equations. It turns out that those lines are horizontal or vertical lines.